Good evening. My name is Yogeshwar, and I'm joined today by my colleague from Hitachi Data Systems, Steven Sonnenberg, and from Turner, Dan Shockley, and my colleagues at Triskel, Loic, Barbou, and Gaurav Bhasin. Today we're going to talk about media orchestration with FIMS and HCP. So, as you well know, FIMS, or Framework for Interoperable Media Services, is a brand new standard that promises to make media workflows or file-based workflows very simple. And HCP, or the Hitachi Content Platform, is a world-class distributed object-based storage. So what can the combination do for us? Let's find out. So we're going to talk about media workflows and how service-oriented architectures and FIMS fits into media workflows. I'm going to give you some examples. I'm going to talk about, very specifically, the repository services part of FIMS and how it can be used to serve up storage. And then I'm going to introduce to you an object-based platform from Hitachi Data Systems for which we are building a repository services connector. And I'll hand that over to Dan, who's going to talk to us about prioritization and requirements of FIMS, and what was the motivation behind FIMS services for repository services from a media organization perspective. We're going to show you a simple demo of the orchestration using the FIMS repository services connector. And finally, we'll open it up to question and answers. So, as you know, over the years, as organizations have started to grow and scale, file-based workflows have become very, very complicated. And it is impossible to have orchestration of these file-based services without having to re-engineer the entire process from start. So several companies have taken the approach of service-oriented architectures, and examples of that include Gillette and Sony. The problem with this approach is that each company has got its own proprietary service-oriented architectures. So what is really needed is a vendor-neutral framework for SOA. And SOA, together with business process management, is bound to revolutionize file-based workflows. And more specifically, we're going to look at the adapter services that is going to be consumed by a client, or in this case, there could be multiple clients consuming the same service. From a vendor perspective, it's important to have a translator which can translate the standard services into something that we understand as Hitachi Content Platform. So the promise of this is that once we've designed this connector, this whole thing can be reusable in multiple situations. All right, so what does it do for vendors as Hitachi Data Systems? Now, many people may not understand our REST interfaces or APIs. But once we are able to translate the Hitachi REST API into a FIMS compliant API, then guess what? It becomes very robust and it's usable on media organizations around the world. And what does it do for the media organization? They don't have to rip and replace their system if their processes change. Their cost of integration is tremendously minimized. It used to be that the media organization would have to work with multiple vendors and make them work with each other. Now that problem goes away with something like a FIMS standard. So here's a great example from Bloomberg of what FIMS repository services can do for a media organization. As you can see, they've used an orchestration service that leverages the FIMS APIs or the FIMS repository services, not just for archive, but also for nearline storage, for production storage, as well as for media asset management and editing systems. So the scope of FIMS is really very, very broad. And our hope is that when vendors like us participate, that we can not just make it highly usable, but also reliable and universal. So to understand what FIMS is, I think it's instructive to understand what it does not do. So FIMS is not a MAM system. It is not a complex orchestration system. It's not designed to manage complex relationships like parent-child relationships between media assets. But what it does promise to do is the ability to manipulate metadata and able to do simple media operations like create, read, update, and delete from the repository without having to stick to any vendor-related APIs. So in short, it makes the whole system interoperable among multiple vendors. And it presents a method for a MAM system to create nice orchestration services around the FIMS repository service. So let's talk a little bit about object-based systems or object-based storage. So what is an object? Here you see a picture. Now in traditional file-based storage systems, this would be stored as a file, and you would not know much information about this. So that would be a traditional system. However, there's a lot of system metadata. Object-based storage, essentially, at its core, separates the metadata from the file. In fact, they could be stored in separate LUNs within the object storage. So here's an example of the creation date, the modification date. Those are all system metadata. However, another layer of custom metadata, such as what this is all about. Is there an object? Is this shot in a particular location? So all of that information can be captured via custom metadata. So the power of object-based system is now the ability to query against custom metadata and not having to touch the basic asset. So Hitachi created a world-class distributed object-based storage, and at its very core, it created a system that's amenable to cloud-based storage, distributed storage, as well as connectivity via REST APIs. And that's the connection between FIMS and Hitachi Content Platform. You're able to connect up the old world of access via CIFS and NFS with the new world of HTTP style access. But for a media user, if the object repository did not have a lot of features like versioning and the ability to, for example, spin down and protect the content, then it would be just a dumb storage. So we have now a great object-based storage ripe for a FIMS interface to take advantage of. So via the FIMS connector, a SOAP REST API, you can extract and tap into the power of object-based storage. So what we've tried to do is we've developed a client that conforms to the high-level requirements of FIMS, and we try to validate that it meets the requirements with the help of our partner, Turner. So I'm going to now hand it over to Dan, who's going to talk about design considerations and the prioritization of FIMS and what's important for a media organization.
So as a broadcast industry and as an implementer, there's some design considerations that you need to take into consideration when you're trying to implement FIMS. And these are some of the design considerations. For example, what's going to be your transport protocol? How do you want to communicate with the FIMS services? And so we've implemented in FIMS, we've supplied the capability to implement SOAP and REST. REST is new this year. It was one of the things that the industry is really starting to ramp up on, is lots of REST interfaces. Synchronous versus asynchronous. So you might have some real-time operations that need to be synchronous, need to be very, very quick, so you would want a request and a response back very fast, or you might have some long-running transactions that you don't want to tie up a whole thread or a whole process with, so then you would do something in an asynchronous fashion. So you'd need both of those constructs to be able to actually implement an integration over a service. You need also to make sure that you can allow for permissions, what services can actually do, and based on who is actually doing that. It might actually be a permission that is service to service, it could be user to service, but you need to have the capability to pass credentials to the sessions. Then there is this event-driven design and this event model that you'd actually want to be able to implement, so that you have a way to actually start some kind of a process or something to happen. You don't want to keep polling, you want to be told when this thing that you want to start would happen. So you could use event-driven design. And then you also want to be able to expose the properties and configuration settings and implement behavior as a service. So through an RCR or a resource configuration registry within FIMS, you're able to actually do something of that nature. So the FIMS repository interface design, and you can see there that, again, FIMS is a framework. So what we've given ourselves the capability of is actually driving that through an orchestration system. So you have the FIMS repository interface. This is the RCR I just spoke about, Resource Configuration Registry, that gives you the capability to configure this service for different resource utilization. And then this is the FIMS repository event notification, so that you actually have the way to listen to events, listen to things that are happening within that repository. That's very, very important. You also want to be able to retrieve things from the repository, and so you want to be able to search for specific things and retrieve those out of the repository. And this is where we're actually going to be exercising CRUD functions. We're going to be doing things with the repository. We're going to add content, retrieve essence, and keep in mind that when we're talking about a repository service, we have both content and we also have the essence that we're talking about. Then there is process events. And again, we're talking about being able to do purging, being able to do this all through notifications, and have callbacks in a synchronous operation. So I can have a long-running transaction. Instead of sitting there waiting on my thread, I can just listen for what's actually going to happen on a callback. Again, that's an asynchronous model. So the FIMS asset concept, and basically what we want to do is make sure that we have both description and design, a common representation of the actual media objects. That's very important. These are one of the considerations that you would have to put forward when you started to design this thing. You would have to harmonize your metadata, and you'd have to think about what this representation would actually look like. This is one of the biggest things that FIMS actually offers. There's lots of organizations that put together what this metadata model would look like, and that's key because when you want to actually communicate across services, how are you going to communicate? What's the dialect you're going to use? So you need to have some common representation of the metadata object, and it also needs to contain the editorial metadata and the physical locations of that media, so you need to be able to find the media. And what are the formats, what's the file structures? These are the things that would be required in this metadata model. And again, lots of industry experts were together to build this. So the design, you have a BM content type that has many formats that could have lots of different files, and then you're going to point to those files through these essence locators. I jumped really fast. Contains editorial information and asset identifiers. And this contains information about the format, that's the format bit rates and resolutions and so forth. And then the actual location, the physical description of where these things would actually live, essence locators. It actually gives you the capability to do component-based formats as well. So the FIMS repository service adapter implementation considerations. Again, what we decided when we first went to the drawing board to draw up what this service would actually include was we needed to have basic CRUD functions on assets, and it had to be native support for HCP. Had to have a mechanism for handling versioning of assets. Again, HCP supports that. Simple locking capability, so you don't want to step on yourself. You don't want your asset management system to step on itself, so you have the capability to actually lock these assets. Management of simple and self-contained media assets, as we said. We talked about a component-based format that you could actually utilize. There's this creation of a FIMS GUID, so that is something that could be globally unique within that repository. That gives you a way of actually identifying each of these FIMS assets. And this can be done through FIMS, or you can actually plug in your own GUID. This is the repository capabilities registry that I talked about before. One of the things that we described when we were building the FIMS interface for the repository was how will each of the vendors implement this, and what are their capabilities going to be? So we built in this capability to have vendors implement what they can implement and actually have it callable, so you could call it through a program and figure out what the capabilities of that particular resource would be. And then again, here's the event model that allows external systems to subscribe to that repository endpoint and listen to events that actually occur on the repository, rather than doing long polling or polling of any nature.
Thank you, Jay. Thank you, Dan, for that great introduction of FIMS repository and the Hitachi platform. We are now going to transition to more to an architecture in terms of how the Hitachi system was exposed as a FIMS repository interface. Let me actually jump to the next slide there. So what we've done is we've taken the HCP platforms, and we've taken the Triskel adapter. That is an adapter that has the ability to morph to vendor API and to expose itself as a FIMS interface on the other side. In this particular instance, the other side is the FIMS repository interface. So in order to demonstrate that interface, we actually created a simple web user interface that we will use to basically do a couple of operations. We're going to create some content, we're going to add some media essence, then we're going to get the metadata get the metadata of the object itself, update that metadata, retrieve the media essence, and then remove and purge it. One additional comment that I want to make around this is, and that's really the big difference that exists between the out-of-the-box Hitachi API and the FIMS repository. This is now an object-based storage, not a file-based storage. So we also have embedded within the adapter the ability to manage, control, and store metadata within the storage itself. So what we have here described is a simple user interface that leverages the FIMS repository interface. And the way, there's a couple of interfaces that are exposed as part of that service. The first one described by Dan was the RCR. So that's a service that you basically connect to retrieve the capabilities of the service itself. That's being demonstrated by clicking on here. Clicking on that icon does one thing. It makes a call to the RCR and retrieve, in this scenario, two properties. The first one is the in, that represents the ingest folder of the repository itself. And the second one is the out, that is the outgest folder. So remember, within the FIMS repository interface, we're not giving access to the end users to all of the files and folders of the storage itself. That's being abstracted by the service. Okay? The way you interact with the service in terms of dropping files and receiving files is by interacting with those two folders there. Okay? So the first thing that we're going to do is we're going to create an object. We cannot create a media asset without a media file without creating an object. So let's go ahead and create this. Okay. Maybe test 2. Category short form, and today is 4/8/2014. Here we go. I now have an object stored in my repository. Now you're going to tell me that was very fast. Well, when you deal with the FIMS repository interface, there's really two categories of operations. There are the operations that exist on the metadata itself that are very fast. At the end of the day, they are similar to database operations. And you have the operations that act on the essences of the physical file themselves. Most of those are asynchronous operations because it takes time to move a file from one place to another place. In the scenario of the repository interface, to really ingest a file within the repository itself is something that can take quite a while if you're dealing with a large file. So that will be demonstrated next. So what I'm going to do here, I'm actually going to, before showing you the file exists, this is the Hitachi content platform. You can see that there's actually no files in there. Okay. What I'm going to do is, where is this file now? Okay. I'm going to go to my ingest folder. I'm gonna pick one of those files. Let's take this one. Okay. I can play it here. So that's what I see in here. Okay. Here we go. So that's my file. That's the one I want. Okay. Now, let me copy the path there. Come on, let's go back here. .mp4. Here we go. So when I'm clicking on the plus sign here, the file is actually being ingested now within the repository itself. So that's an asynchronous operations. So it's taking a little bit of time. If I go to the Hitachi storage here and I refresh it, I can see that the file is being copied there. If I go back now to my application, I can see that I should have received a notification here. It's coming, be patient. Okay, let's move on, that's gonna come. What I was waiting for there was for a callback from the server itself to tell me that the file was fully ingested as a response from the callback of the original operation that was made to the FIMS repository service. Okay, the next thing that I'm going to demonstrate here is, now that I've created the metadata around that object, I may want to change it. So I have the ability to go back to the metadata that was already associated with that object and change it after the fact. Okay. Okay. Now let's go back here to make sure that the file is actually fully in the Hitachi system, fully ingested in the Hitachi system, and it's there. Okay. And what I am going to do now that the file exists is, it's in my storage. I want to retrieve it. I want to check out the file and I'm going to do something with it. So how do I do that? Well, let's take a look at one thing here. What you see here is represent my out folder. I'm going to refresh it. I'm going to refresh it. There's nothing there now. Okay. So I'm going to do a checkout or retrieve essence when it comes to the name of the operation for the repository interface. Okay, by clicking on here. So now, if I go in this one, you see the size of the file? Okay, that's increasing. Now I have my file here. Is the size changing? No. So I have retrieved the entire essence. I can actually play it. Okay. So far we demonstrated a couple of things. Number one, we created some content. Number two, we added an essence to that content. Number three, we updated some metadata. Number four, we retrieved the essence from the repository and we played it. Now we're going to remove the essence or delete the essence. When it comes to the FIM interface, that's a two-step process. First, when you call an operation that is remove essence, what you end up doing there is flagging that essence to be deleted. You actually don't remove the bytes of that physical file from the storage itself. The second operation that you can call on after an essence has been removed is purge. The purge will actually destroy the bytes, the bits of that content from the storage itself. So let's take a look at this. Step one, I'm gonna click on that icon there. How long do you think that's gonna take? Remember, we're flagging that content for deletion. It's a synchronous operations. We're just setting the metadata on that essence to be removed. Okay, was fast. Okay. Now the next operation is going to take a little bit more time. Okay, so this one. Now going back to the storage itself, if I look at this, if I refresh the page, what should I see? Well, let's see. It's gone. So it's now removed from the repository itself. Okay. Now the content still exists. Okay. So, and that's being flagged as being purged in here. So the object is still in the repository. I just remove the essence. I can go back and add a new essence from there, or add even multiple essence for this object. FIMS supports that. There's some operations that haven't been implemented in here in terms of metadata management. There's also events and notifications as described by Jay and then around the repository interface that haven't been implemented in that sample applications in terms of progress of operations, but that's something that can easily be added to this. So that concludes the demonstrations of exposing the FIMS, the Hitachi HCP product as a FIMS repository interface. Thank you, everyone.
Thank you, Loic. Thank you, Dan. So we now open it up to Q&A. So just once again to recap, we talked about the requirement or need for FIMS and what problem the FIMS solves. We talked about Hitachi's object storage platform and the connector that can be used with that to connect via FIMS to HCP. And we showed an actual example of media orchestration using the FIMS connector with HCP. So today we showed some of the basic operations, but the potential is there to use the entire set of objectives in a real media orchestration and media facility and get the power of FIMS. So I'd open it up to Q&A if anybody has any questions on this. Yeah?
In addition to storage repository adapter, what other functions are being created or adapters being created for workflow functions?
So again, the workflow related capabilities reside in the MAM. So the FIMS orchestration is done on a MAM system. What the FIMS repository service is, it gives you the tools necessary to go and read from the storage and manipulate the storage and read the metadata, search against it. So it is just a tool to simplify the media facility. So now you're not dependent on just one vendor. So for example, I could remove the HCP and put in another vendor storage platform that supports FIMS, and none of the operation changes. So it's very transparent to changes in the underlying hardware.
So what's the best process for vendors to onboard themselves into the FIMS organization?
Okay, that's a question for Loic.
So as a vendor, what you can do, you can join the FIMS technical board. That board is composed of today 165 members. Those members are basically working on different projects, and we have subgroup defined for that. And one of those subgroup is the FIMS repository team. Hitachi is part of it. Turner is part of it as well. Other questions? Okay.
Thank you very much.
Thank you, everyone.